So this next video, we've already talked about how to do a center of mass for a uniform rod. We've talked about how to change that to arcs. The next thing I want to talk about is how to do a non-uniform rod. Give me just a second. And let's do a screen share. Okay, and so we're kind of back to our first code of the day. So let's just walk through it. We have the rod length, the X min, the X max. We've figured out the number of slices and the total and the spacing. Now, if the mass density is non-uniform, for example, let's say mu of X is some function Kx, where K is some constant. You could check the workbook. I think 9.33 will probably be the number. You could double check. What do? Well, we can't just tell everybody mu is mass over length anymore because we don't know the mass. And we can't just say it's some number because it's not constant, right? As you move over, we could think about what we should see. We should see almost no mass at the beginning because X is 0, right? This thing is lined up on the coordinate system like this. Okay. We expect no mass, then maybe a little bit more mass, then maybe a significantly bit more mass, then maybe a lot of mass. And then in this particular case, we expect 5. So we're going to expect a lot of mass way over here. All right. And so we expect the mass to get bigger. As such, we expect the center of mass to maybe shift over from right in the middle to maybe being closer to here. That's what we expect the code to compute, right? We know the density is increasing. And each one of these balls now will have a different amount of mass associated with it. How do we code that? Well, let's take a look. First, let's just pick a number here. We could always change this number later, okay? Now, we're still going to draw our visual guide and all this stuff, so none of that has changed. We're still going to draw a coordinate system. We're still going to have a numerator. Basically, we still have all of this. And you've noticed I'm going to use the for loop here. So I think it just cleans things up a little bit. X has not been defined already, but this for loop creates it. This is going to go in here. We're going to go from the minimum to the maximum in increments of dx. Nothing has changed. We're going to draw the sphere. We're going to put it in the right spot. We're going to deal with this x over 2 just so it converges rapidly. We've discussed that. Nothing has changed here. However, this is where things get weird. Let's look at that line. This is no longer true. We don't have a value of mu anymore. Now, here's the thing. What is mu? We've discussed this already. If you've forgotten, we're assuming that mu as a function of x is no longer a constant value. It's equal to kx. Well, all you have to do, we know what x is. We know what k is. So we replace mu with the value of mu at this particular position. So that will be k times x. So that, let me just put some parentheses around it to make it easier to talk. The thing in parentheses is the value of mu at each different ball's position. Okay, now think about what the code is going to do. You're going to come in here and start with x equals the minimum value. That was 0. So let's go through the code as if x is equal to 0. We're going to start at 0. We're going to draw a sphere. We're going to move that to this position here. This was also 0 in the code. And so that was a 0 vector, the origin. We're going to start at, we're going to put the x coordinate at 0 plus half the increment size. Got it. And now the mass at that position, ooh, what do you think? I bet this is a slightly funky thing. We should probably say x, x plus dx over 2. Obviously, if we use a large amount of spheres, this wouldn't matter. But let's think carefully here now, right? So the ball's position is at that location. We should probably use the density value at that same position. So maybe so we didn't have to write this so much, why don't we, instead of having to think this through, maybe ball.pos .x would have been a smarter way to reference that. right? Because now I'm saying, look, this is the x coordinate of the ball. Use that x coordinate to get the mass, and then I wouldn't have had to remember all this junk, right? So, and it takes care of all this other stuff as well. So I think that's probably a little bit smarter way to reference that equation. So now when we run this thing, let me clear the annotations and run this thing. Are there other correct ways to do this? Yes. If n was very large, would this distinction matter? No, not that much. But again, we want our codes to be as efficient as possible. All right, so when I run this one, oh, what did I forget here? Oh, I bet somewhere deep in the code there's another mu that I forgot to take out. Yeah, in this, in all these percent differences down here, there was a mu right there. You see it? So let me go ahead and get rid of this. Let me comment this out. Sorry about that. Forgot about that. All right. There we go. And so now, oh, it's not drawing the center of mass and printing it out, but we do see it's actually printing these spheres. Now, a subtle thing that is going to be, you might say, well, boy, it's kind of hard to see which mass is the biggest. One of the things you could do is you could recolor the masses and their opacity or something to give a color or opacity that changes as the balls go side to side. This is all icing on the cake. So if you want to stop the video here and just get to the code and get it over with, that's fine. But if you want to think, how could I recolor the spheres so that as we were drawing earlier, remember we said this one has almost no mass and then this one has a little bit more. Let's just draw 5 really quick. So what if we wanted to change this? So this one has almost no color. This one has a little bit more color. This one starts to get significant. This one's almost completely colored in, and this one is completely colored in. So the idea is, what if we want to adjust the color scale so that this one on the right end, which has the most mass, looks the most dense in terms of its opacity? Well, what we could do is we could, now this is tricky, we could, there are many correct ways to do this. I think it's worth learning this method that I'm about to show you. So one thing you could do is you could go into this code. Obviously, all the other code is exactly the same, right? But what you might want to do is we could come in here. Let's define a term. How about this? Let's say dm max. Right? And so this is initializing kind of a counter. So what I'm going to do is I'm going to say, look, right now, before I get to the loop, none of the masses have anything. So the maximum value of all the masses is 0. I don't have to worry about it. So what I'm going to do is I'm going to stick in a statement down here. And what we'll do is we'll just say if, so this is an if statement, if rod I dot dm is greater than dm max. Okay, so this is now a statement with a colon inside of another statement. So when I hit enter, notice there's 2 indents. So right now I'm not just in the while loop, I'm in the if statement inside the while loop. So if that is true, what I want to do is I want to update the value of dm max. So let's do this. Okay, so if, let's read this through. If the mass of my particular sphere, remember, what does this do? Okay, let's start at the while loop. Okay, we're starting with I equals 0. We come into the while loop, we draw the ball, we get the mass of that thing, and we append it to here. We do the center mass summation for this particular term. And then we get to this if statement. It says, okay, I is still 0. Go to the 0th object in rod. Well, that is the ball. Okay, go to the ball, get its dm. That's this thing. Okay, got it. So now I get that mass and I compare it to the largest value. If it's bigger, take the old value of dm max and update it with this one. That's all that does. So now if we run this, let's make sure I didn't introduce a typo. Okay, nothing happened. It's good. So it's still running. Now what we could do is after all of this, we could do this. Let me get a for loop. So for ball in rod. Now, what this is going to do, notice I want to be clear here. This is no longer indented. So to be clear, here's a for loop. I'm going to come into here and do a bunch of stuff. This is in the if statement. So this is indented an extra time. This is not indented. Therefore, we're back in the while loop, not in the if statement. Okay, so because this is unindented, we are no longer in the if statement. Fine. Now this is unindented, so we're no longer in that first for loop. This is a second for loop. And this is where the lists come in really handy. For each ball, that's for each object in the rod, you could call it for each taco if you wanted, right? Let's do that. So for each taco that's in the rod, that just says go through the rod and get each element. Okay. What we want to do is we want to change the, let's say taco dot color equals vector. Let's make them red. So now that changes the color to red, but let's also change the opacity. And then what we're going to do is we could take, that will be the taco dot, let's see, taco is a sphere. So let's see, it's going to be the taco dot dm divided by dm max. Now think, oops, let me get this down here just a little bit. Think what this is going to do. Let's see if I got it right. I'm just doing this on the fly, always dangerous, but let's see. So this says pick an object that's in the rod and give that object the name taco for this particular for loop. Fine. Go in and take the first object's color, change it to red. Next, take that object's opacity, and I want you to look at its mass, divide that by the maximum value, basically take a ratio of each one's mass. And just so we could see this happening live, let's put in a rate statement. So we'll do this 1 per second. And then let's see if this runs. Hopefully I didn't screw this up. That should go in and make the lightest mass. Oh, let's see. Did I forget a punctuation here? My bad. For taco in rod. Maybe oh man, this is, let's see what I forgot up here. Let me see if I need to take this out. Sorry about that. There we go. Sorry about that. And I don't know if you could tell, but it seems like it's working. The sphere on the right is the most red, and the sphere on the left is the least amount of red. So this gives you a visual appearance. It just kind of helps you see things a little bit better. Is that necessary? No. But again, what was the error? Just in case Zoom lagged while I was doing that, the error that I had just done. Notice when you refer to this, I had accidentally typed in the square brackets as well. And the code was expecting, it knows that rod is a list already, right? So in this weird case, yeah, I don't want the brackets indicating that it's a list. It already knows that it's a list. So we see this is kind of useful to now have the list because we can do things like this after the fact. I'm going to stop the share.